and share the screen. All right, so in today's lecture, let's still focus on the loops and iterations. Okay, so in last lecture, we introduced the concept of loop. So basically in a loop, it's like you are repeating something and in each of the steps, you will do something and change something. and turns out you could usually use to scan an array or a set of data from the very beginning to the end. That's what loop does. And as you can see here, here is a typical case for a loop. And this is the so-called while loop. You can see the reserve word while here. Basically, after the while, it's a condition. In each of the steps, this condition will be checked, whether this is satisfied or not. If this is satisfied, then the code under this while loop will be executed. And of course, you need to change something, some value, some variables. And it is related to this condition. And after you have done one step of the job, you go back to this while and check whether this condition is satisfied or not. If it is still satisfied, then this loop will be continued. Otherwise, you just go out of the loop and go to the next line of the code. So that's how a loop works, especially a while loop work. And we also talk a little bit the infinity loop. Sorry. I think you guys have tested with the Jupyter Notebook. I just want to tell you, when last time I tried on my computer, basically this infinity loop generate a really large file on my computer. And it turns out there's only a few hundreds megabytes remained. And I have to restart my computer to release the memory. So, but the idea is, it is an infinity loop, means it will repeatedly go inside this loop and do something, and this will go on and go on. So that is the so-called infinity loop. So a typical problems for this infinity loop is this condition. So basically this condition will determine if the code under this while will be run or not. So in this case, we set n to be 5, and then we check if n is greater than 0 or not. And because initially n is 5, so this condition is satisfied, then we go inside here and print these two lines. But afterwards, we did nothing to n. That means n is still 5. And then we go back to check this condition in this line, and still it is satisfied, and these two lines will be executed, and so on and so forth. And this will be infinitely repeated. So that's how an infinity loop is generated. Although this is a very simple case, meaning it's so obvious you do nothing to the end, but there could be some cases that this condition is a complicated representation, or you need to calculate something, and that value need to be checked as a condition. And but same thing, when an infinity loop happen, check this condition. It has to be something wrong with condition. You must haven't done something correct when you should change this condition, to change the variables I mean the variables related to this condition. All right, that's the infinity loop. Any questions regarding this infinity loop? Okay, good. Let's move on. And then we have another loop. So I think it's a very simple one, so I won't let you key in and test in Jupyter Notebook. But this is another problems when you are writing a loop. That is, the code under this loop are never executed. Why? See, again, check this condition. So this condition is checking whether n is greater than 0 or not, but the initial number of n is 0. So that means at the very beginning, this condition is not satisfied, meaning these two lines of code are never executed and will never be executed as well, because once this is not satisfied, it goes to this line directly and it does nothing. And this loop is not a real loop, it's not executed. So together with the infinity loop, these are the two most commonly happened error in your coding. That is the infinity loop and the loop it never runs. So be aware of these two types of errors. And the key is the same. That is the conditions for while loop. All right? So when you do a loop, there are some special statements which will end the current loop and jump to the statement immediately following the loop. So that is the break statement. So if we look at this loop, basically while true, and if this is satisfied, this line of code will be executed. And because you are setting a true here, that means it is always satisfied. And then this line is asking for input from the user, and you could input anything, right? But there's an if statement. Basically, it checks whether the input string is done or not. If it is the case, the the break statement is executed. Means from any line after this break inside the while loop will be not executed, and it directly go to this print line. Otherwise, if the input line is not done, it will execute this print line code, and it go back to the while, because this is not a variable, and this condition is always satisfied. So it goes to this while again and check and waiting for users input, and again and again. So if the user never input a down, this will become an infinity loop. But once user input down, this will it will go outside of the loop and go to the next line after the loop. All right. If you look at some examples here, basically you could input hello there, and because this string is not done, it will not break, and this string will be printed. And or you could print finished. You could input finished, and still it is printed, but the loop will continue. And finally, the user input done, and it turns out this loop is terminated. That's the the break statement. Basically, it will end the current loop once the break statement appear. All right. So here give you a illustration of about how a break work when you goes to this break statement line. Basically, it will directly go to the next line after the loop. All right, as I explained. Any questions? All right. So again, if you can check this illustration figures to take a look how break work. But just as I mentioned, it's basically once this is executed, the loop will be terminated. All right. Another keyword, reserved word is continue. So the continue is a little similar to break, but the difference is when continue appears, the code after the continue, but inside the loop will not be executed. Instead, it go back to this while, go to the beginning of the loop and check this condition. It won't go outside of the loop, go to this line. No, that's not the case. But it goes to the beginning of the loop. And anything after this continue will not be executed. So that's how continue work. I would like to give you a few minutes to type in this line of code to your Jupyter notebook and check what it look like. Okay. Okay, you can start to key in your Jupyter notebook. You can use these lines. The line you can use this as an input to see what's going on over there. All right. So I will give you 5 minutes to test it. Okay, I think you have testified yourself, right? So as I mentioned, when you have a continued, that means, okay, basically you just want to go back to the beginning of the loop and check the condition. And that's the difference between continue and break. For break, basically, once break appears, this loop will it will jump to the outside of a loop, and this loop is terminated. And any line after the break will not be executed. So that's the difference of the continue and break. So basically, when you're gonna need break or continue, so just imagine you set up a criteria which is the condition, and this criteria need to be evaluated every iteration. But for some special cases, you just don't want, no matter what the criteria, no matter what the value is, you just don't want to do the computation anymore. You just don't want to stay inside the loop anymore. At that time, definitely you need a break. When that case happens, you just want to terminate the loop and go outside of a loop. For the continue, so basically there are few cases which have slightly different computation other than other cases. Then that means you only need the step. For example, there are 4 steps of the operation for inside the loop. And for some cases, you only need step 1 and 2, but not 3 or 4. That means if that's the case, you want to just perform the step 1 and 2, and not 3 and 4. For example, if the step 1 and 2 are they are before this continue. Let's see, step 1 and 4 are here, 1 and 2 are here, and 4 and 3 and 4 are here. That means, okay, you have done 1 and 2, and that's the case, and which is enough for them. Then you just skip step 3 and 4 for such case. Then you set up the condition and to check, okay, that's the case. I just need 1 and 4 step, but not the step 3 and 1 and 2 step, not 3 and 4. And then I just go to the beginning of the loop and do the next step. So that is how continue will work inside a loop. All right. I think we can have some examples later to have some idea how a break and continue work together with a loop. But now you just conceptually understand it. Any questions?
I'm a little confused on the third line, just because we've never seen like the line and then open brackets, 0, close brackets. Could you talk a little bit about what that means?
Oh yeah, that's a good question. Let me first clean this up. It may be messy. Oh, so basically, as this line, right, actually is a string, and the value is assigned by the input function, right? You can imagine you have a string, and each of the character of the string, you can imagine it's a queue or an array. And if you use this bracket and put a 0 here, that gives you the idea that is the first. If we take a look at this line, right? So this is the string, and this is the first element, right? And this is this space is a second element, the second character, and this D is the third, and this O is the fourth, and so on and so forth. But in coding, the first element in an array, we usually use the ID 0. So the index starts with 0. So this is a 0 index, and 1 and 2 and 3 and so on and so forth. So basically this line of code actually means you are looking at the first character of this string and check whether the first character of this string is this hashtag or not. That's it. You got it?
Yes, thank you.
Okay, good. Yeah, I think that's how a string is represented in Python, and I will definitely introduce more when we talk about the files and also the text operations. But let's move on. And also, if you look at this illustration figure, it gives you the idea of how continue work. All right. So there are other types of loop, which is called the indefinite loop. So this while loop is the indefinite loop because basically it will keep going until a condition is satisfied, which is here, right? After the while, there is a condition is checked. And basically, only if this condition is not satisfied, this loop will stop. So that is so-called the indefinite loop. So again, you need to be aware, you don't want to make it an infinite loop. You have to properly set up the checking conditions and make sure this condition could be achieved. Otherwise, it will be an infinite loop. Also, you need to look at the condition again to make sure at least at the very beginning, this loop will be executed. So just to avoid the two cases, infinite loop and also the loop, and the loop never executed. All right. That's the while loop. Also, we have another type of loop, which is the definite loop. Usually we use the keyword for. And if you look at for, it is a definite loop. And let's look at what it looks like. So basically, the for loop is quite commonly used to check a list of items. And because it's a list of items, that means you have a finite set of things. And in that cases, a definite loop is required to check each of the elements inside the loop, inside the line, inside the list, and do something to each of these elements. And that is how this kind of definite loop work. We always say the definite loop iterates through the members of a set or a list. So let's look at another example. So as you can see here, this is a list or a set, and basically it has a number of a few numbers inside, 5, 4, 3, 2, 1, right? And this I is a variable, means each of the element inside this line. And basically, if you look at the whole line of this code, basically it says, okay, you want to check each of the elements inside this list. And for each of the elements, you just want to print the value of that element. And after you have gone through all the elements inside this list, you just go outside of the loop and print this blast off. So that's how a definite loop works. So I will give you 1 minute to key in your Jupyter notebook and see how it works. And again, this colon, see, colon. For while loop, also there's a colon. And it is also true for the for loop, all right? Just go ahead and test it. Okay, let's move on. So there are different types of variables you could loop through. For example, you have an array with set of strings, and in this case, they are names: Joseph, Glenn, Sally, right? And you can loop through them. Basically, for friend in friends. So this friend is a variable, and this is friend. This friends is this array. So that means you want to take every element of the inside this array friends in this friends array and do something. So what it does is print Happy New Year with a friend. That is one of the element inside the friends array, and it will follow the order from the first one to the second and the third and so on and so forth. So it turns out these 3 line of sentences will be printed, all right? But same format, even the variable type are different, right? This is string and the previous one are integer numbers. Okay, any questions? Okay, so far so good, right? So what actually this does is, if you have this kind of code, what you do is, to first, starting from the first element inside this loop and do something, and then go and then move to the next element inside this array and do something, and then move and then do something, and so on and so forth. So in the definite loop have the explicit iteration variables, which is this I in this case, which also which is also the friend in the previous case. And that will change each time through a loop. It will move forward at each loop, iteration. And basically until it reaches the end of the array. So that's how it works. You got it? So this variable contains both the element of this inside this loop, and also it will move forward. It will change across each of the iteration. When every time it will automatically move forward one step. So that's how this works. And again, here gives you a very simple iterative step, that is go through this array and print each of the element of the array following the order. Okay. So as you can see here, basically it gives you the idea. Okay, for when I starting the very beginning, the I is assigned to be 5, which is the first element in the array, and then you execute the print. Otherwise, and then go one step further, and I becomes 4 and print it, and so on and so forth, until it reaches the end of this array. All right. You might ask, what do we do with the array, and what is array used for? Let's look at some simple examples, but even these are very simple cases. It is the same thing, same pattern as the one you will be using for even more complex cases. And on Thursday's lab session, we will practice some more complex cases. So be aware of these simple examples. So a very essential thing is to make your loop smart. Basically, the trick is you need to know something about the whole loop when you start writing code that only sees one entry at a time. So you have to have a little global view about what is the actually thing you want to do with a set of data. And then you should come up with a simple logic, how you're gonna repeatedly do something, and at the same time you want to make change a little, and then do the iteration again, and so on and so forth. So that's how how you should think when you have a set of data or set of operation you want to do, and you are looking at the loops. Okay. So let's take a look of this. So that's a very simple one. It's almost the same as the previous one. So basically, you have an array with a bunch of numbers inside, and this is the iterative variables thing, right? Basically, you just loop through the array and print each of the numbers from the first to the last. All right, and it turns out this will be the result because you have this print before and print after, behind and after the loop. Then you will have this kind of number printed. Simple. And based on this, if the question becomes among all the numbers, how we find out the largest one. Because there are only 6 numbers. So it's very easy for us to find, okay, this is the largest one. But what if there are hundreds, thousands, or tens of thousands, millions? How are we going to do? So the easiest way is write a loop and use the loop to figure out which is the largest one. And also in this array, the assumption is these are all numbers greater than 0. That means there are no negative numbers. So the idea is we first set up a initial value to a variable, which is called largest so far, and we set it to -0 and use this variable to compare with each of the elements inside the array and see if any of the number is greater than this, then that number will be kept in this largest so far variable. And with the new value, this variable will be compared with another element inside the array in the next step. And this will be repeated again and again after the whole array is gone through. So that's the idea for finding the largest number in an array. So for example, the initial number of this largest so far is -1, right? And the first element of inside this array is 3. And we compare this largest so far with 3 because currently it's -5. So obviously this is smaller than 3. And if that is the case, we let this largest so far to be 3. So we assign 3 to this largest number, and now it becomes 3. Just keep it in mind, all right? And then we check the second number inside the array. It's 41, and currently the largest so far is 3. Whether 3 is greater than 41? No. So 41 is larger. Then we just drop the 3 and assign 41 to this largest so far. And then continue to do the next iteration. And then we move to 12. And because this is variable is 41, which is greater than 12, then we do nothing. That means, well, so far the largest one is 41, not 12, right? And then we go to a next number, which is 9. Again, 41 is greater than 9. Then move on. Oh, currently the number becomes, the number is 74, and the largest so far is 41. So 41 is smaller than 74. Then we just drop the 41 again and assign 74 to the largest so far. And then we check the last element inside this array. This is 15. Well, it is smaller than 74. So we just keep 74. And that's the end of the array. And it turns out the largest number is 74. So that's how we find out the largest one by looping through this array from the very beginning to the end. And turns out we have the largest number is 74. So any questions? Have you understand this? Okay, good, good. So the idea is to define a variable with some initial value and use that variable to keep your result. And every step, you just need to compare this variable with the current element and see whether which one is greater and keep the greater one, and again and again. So if we look at the code, so it's something like this. So the largest so far is assigned to -1, and also we print its number before the loop. Then let's loop through the array. So inside the array, let's look at, okay, if the current element is greater than this largest so far or not. If that is the case, we just use largest so far to keep the current largest number and print it out, the largest so far and the number. And after going through the array, we have the overall largest so far number, which is 74. All right. So that is how it works. Quite simple, right? Just imagine if you have even 1 million, 10 million, or even more data, same code, same set of code. Of course, you need to have a way to keep your numbers inside this array, but once you set it up, all the codes are same. So let's look at more patterns, more examples. So I think it might be a good idea for you to key in this in the Jupyter Notebook. I think this is a very simple but complex enough patterns for a for loop. All right. Let me clean this up. I will give you like 5 minutes to 3 minutes probably. It's good enough. 3 minutes to type it in your Jupyter Notebook and see how it works. All right. Okay. So I think you have practice this code and see what it look like. So actually I have a question. So we set up the initial value for largest so far to be -1, based on the assumption that all the numbers inside the array are greater than 0. So what if the numbers, for the numbers, we have no assumption. It could be any numbers. So in that case, what we should set up as the initial value for the largest so far? Any idea?
Could you say that one more time, please?
Sure. So as I mentioned, we set up the initial value for largest so far to be -1 based on the assumption that the number inside the array are all a positive number, which means they are all greater than 0. What if there's no such assumption? It could be any number, arbitrary number. It could be negative ones. Then what we should set up here as the initial value?
Maybe one of the numbers that's already in the bracket.
But that's risky. You don't know whether it's a larger one or smaller one, right?
Could you just put like n or something in there then as no number? I mean,
there are different multiple ways. I will let you know. Actually, in later slides, that shows demonstrate one way, and I will give you another way here. So what I usually do is to set up a very small number, how small it is. So basically, you could figure out what is the smallest number which Python support, and set that number as the initial number. That means there is no number smaller than that number. That means no matter what kind of number inside this, the number inside this array is greater for sure than this initial number. And then that will make this mechanism work. That's what I usually do, but there are other ways. I will show you what it is in the following slides. But for the way I mentioned, do you get it? Any idea? Okay, good. So let's look at more loops. There are also other functions you could implement using a loop. Sorry. For example, you can count how many numbers inside the loop. Basically, you need to define a variable which is give you the numbers of the elements. So when you loop through the array, inside each of the iteration, you just count. You just add one number to the count, and it turns out after you going through this array, this variable will contain the overall count of elements inside the array. For example, if you check the output, so it will print 1, 2, 3, 4, 5, 6, which is the number which is the count of the array. And it turns out the overall count of the elements inside the array is 6. So that's just one example, very simple example for the loop. Another one is to do the summation, right? Sorry. So what you could do is, again, define a variable, and this variable is initialized to be 0. And then loop through the array, and in each of our iteration, you just add the current element to this variable. And because at the very beginning, this variable is set to be 0. So in the first iteration, this is 0, and this is 9. And turns out this becomes 9. And then basically, it goes to the next step. And it turns out this is 9, and this is 41, and this becomes 50, right? And so on and so forth. Basically, after going through all the elements inside the array, you will have the summation of all the elements inside the array. And so finally, the summation is 154. So that's how you compute a summation using a loop. So because you have seen how to count the element inside the array, and also you have look at the summation of the array, then it's easy to compute the average. So what you want to do is you have one variable which will be used for keep the count of the elements inside the array, and another variable which is the summation of all the elements inside the array. And basically you just compute them, update them at each the iteration. And after going through the array, you will have 1, the summation, and 2, the count. And then you can use the 2 to compute the average. So it turns out it will give you the average of all the numbers inside this array. Okay. And next one is the filtering. So sorry. So basically, the filtering is realized by setting up some conditions inside the array. For example, still looping through the array, but you set up a condition here. So this condition is if the element which is kept in the variable value, and if value is greater than 20, do something. In this case, it's printed out. And that's how it works. Sorry. In this case, there are only 2 numbers satisfies this condition, right? 41 and 74. That means only value is 41. This will be printed, and only another satisfied case is value is 74. This will be printed. Otherwise, all on other numbers, this will not be printed. Although it's just here, it's just a very simple printing function. Sorry. You could imagine you could do something else, right? By setting up some conditions. So you only do something once these conditions are satisfied. So that is the so-called filtering. Basically, you are catching some of the values you are looking for, or skipping some values you don't want to have. So that's how the filtering works. Or you could use a Boolean variables. So for the Boolean variables, basically there are 2 keywords, false and true. So basically for Boolean variables, there are only the 2 numbers. It's either false or true, either true or false. So that's the Boolean variables. initially found is set to be false, and then print one line, print what found is, and then loop through the array. And basically there's a, sorry, there's a condition set up here that is only value is equivalent to 3, the found is will be set to true. And that's the case. So as you can see here, when we run the code, sorry, when starting from the first element, which is 9, and 9 is not equivalent to 3, so found is unchanged. And then go to the next step, value is 41, still not equal to, not equivalent to 3, so this will not be executed. 12, no. 3, okay, finally, found is set to be true. And when go to 40, when go to this element, basically, even this is not satisfied, but the variable found has been set to be true, so it is still true. And 15, still found is still true, even this line of code is not executed. Okay, that's basically, it's like you are switching, basically you trigger a switch from on to from off to on, and you never switch it back. So that's how this code work, and how it does to this Boolean variable found. Okay. So any questions? All right, let's move on. Sorry. So we have gone through the codes for finding the largest values. How about we change it to finding the smallest one? So here you are seeing this. This is the original code for finding the largest values. Let's make some changes to the original code and change it to find the smallest value. So I think one direct thought will be, okay, how about we change this greater than to a smaller one? So that is something like this. And you can type in this to your Jupyter notebook and see what is the result and see whether it works or not. And go ahead and test it now.
It uses -1 as
Exactly.
the smallest.
If you have
That's
the
what we were sort
negative
of talking about
one,
before.
yeah. If you have the number to be -1, that means it doesn't work. And but that's this line of code supposed to do. That means there's something wrong. So the reason is basically this -1 is not greater than any number inside this, because these are all numbers greater than 0, and -1 is smaller than 0. So that means this condition will be never satisfied, and this small list so far will not be changed. So that suggests us, okay, probably you have to do something to this initial value of smallest so far. So what as I mentioned, there are multiple ways to deal with such cases. I have introduced one way, but that's for the finding largest numbers. Here shows another way. It works both for the smallest and the largest. So that is, sorry, you set a none here to be the initial value of your variable, and then go through the loop. And it turns out you need to have a if-elif system and check whether the smallest is a none here. That means, well, this hasn't contained any values. This is the initial value. And then you just set up whatever value current is, and to be the number of smallest. And then continue looping through the array. So actually this condition will be satisfied only at the first iteration. That means when value is 9, so this smallest number, this smallest will be variable will be set to be 9, and afterwards this will never be satisfied, and it goes to here, and again this value and the smallest value are compared. If this value is smaller than the smallest one, then use the smallest one to keep the current value, and repeat this process again and again. You will, turns out, find out the smallest one. So basically the key here is to set up an initial value to be none and check it inside the array to do some special treatment. That is, if the smallest smallest variable is none, you just set up the current value no matter what it is, because this smallest value contains nothing. You have to give it something which is one value of the array, and in this case it is the first value in the array. And then afterwards, in the next step, you just do the regular comparison. So that's it. So you got it?
I'm getting 9 for the smallest.
You mean the for this one, right?
No, for the new one.
Oh, for the new one.
Yeah, it's not giving 3, it's giving 9.
I think you can show me later on after I complete all the lectures. I'm pretty sure there will be some bugs, but I will check for you, okay? But now let's just move on. And yeah. So that is how you make such kind of code work. If we go back to the previous question, that is the largest number. I was asking you, okay, for finding the largest number or largest value, and with no assumption that this must be positive, it could be anything, then same method can be applied here. put it to be none, right? And check, okay, if it is none, then set up the largest number to be the first element. And then for all the rest steps, just to do the regular comparison. In the largest case, that is greater, right? But similar as here. That's another way to deal with such kind of problems.
I found what was wrong.
Oh, okay, good. So here there's a special operator here, which is called is. So this is operator implies is the same as, it's very similar to this operator, which checks the whether the two values are the same or not. But it is stronger than this in the sense that basically it checks whether they are the same thing. So for example, you could have two variables, but it contains the same amount of number. For example, you have a variable A and a variable B. They both contains the number 4. So if you use this operator, check whether let me maybe write the code here. That will be more clear to you guys. So you have a variable A, you have a variable B, and if you write if A no, I mean B here, not 4. Print all right. So tell me whether this line of code will be executed or not. Come on, give me some feedback. Do you think this line of code will be executed or not?
No.
No, why?
Because it's saying if A, it's not if A is equal to B, it's if A is the double equal. I don't know the.
Actually, this double equal means to compare the number of A and B. Remember, this equal sign means the assignment of value. Basically, it assigns the value on the right-hand side to the left-hand side variable. But this double equal, this sign means comparison. So it compares whether the value of A and B are the same. In this case, they are the same. So that means actually this line of code will be executed. But, sorry. But if we put if A is B, actually in this case, this line of code will not be executed because this is stronger than the comparison operator. This will be true. This will be. I mean, this situation, this condition will be satisfied only this A and B are the same object. So it will never be the case. They have the same value, but A and B are two variables, and they are not one variable. So this is not the case. So that is what the what the is operator does. So similarly, there's another operator called is not. Basically, whether it checks whether the two variables are the same one or not just to check the value. All right, that's the difference. So that's how you come up with the smallest numbers. So I would like to summarize today's lecture. So we talk about the loops, the indefinite loops, which is the while loops. And for while loops, you have to be aware of the infinite loops. Also the loops that is never executed, right? Because the condition you set up there, something wrong. Also, how to use the break on continuous statements in different cases. Then we talk about the for loops. The for loops basically is used for scan a series of data, which is stored in a queue array. There is an explicit iteration variables. Also, what you can do with the for loops, the different patterns for the for loops. And also we practice some examples, something like the largest number and the smallest number lookup, all right? So I think that's all for today's lecture. And let's do some practice on Thursday's lab session with the for loops and also some combinations of what we learned so far. All right. So that's the end of today's lecture.
Thank you, Professor. And I'll see you Thursday.
Yeah, see you guys.